Hi students, this is Hatiram. Today I am going to discuss regarding to concept of sets. So set is a well-defined collection of distinct object is called as a sets. So this is a very important lesson in your class 10th. So student may can think that why to start this lesson learning. This is in our day-to-day life we used to use this concept in many aspects. Before that is in 10th class point of view, if you'll see that the students who will appear for the class 10th final examination, they usually get minimum there is 4 marks they can get in this and maximum in the year of 2018 there is 8 marks has given from this lesson. So minimum in 2016 there is a 4 marks is given. So I can say that a student who can able to pass easily by learning this lesson, because among all lessons in class 10th out of 14 lessons, this lesson is a very easy. There is no more calculations will be, there is some idea will be on the numbers, they can able to achieve marks in this lesson. So let us start the concept of sets. Generally speak, regarding to your classroom point of view, in your class there is a boys will be and at the same time girls will be. So boys is nothing but a collection of objects. If you think, then boys is nothing but a set. Girls is a collection of objects. If you will feel different names in your class, girls names, then this girls is nothing but one set. So set is simply collection of objects, and those objects should not repeat, means all they should be distinct, means different. Okay, the objects in the set is called as elements. So let us say boys, a few names, let us take Ramu, Raja, and some name thing that is some Revant. So don't think that is Allah starts with R only. Just I wrote simply. So each member is nothing but called as an element. So these elements all are different. If there is a two Ravens are there in the class, don't write it, because they all should be different. Different is another synonym word, is nothing but distinct. So each element, each object in the set is called as the element, and these sets are basically represented with curly brackets. Okay, girls, let us say Sanju, okay, Raji, or another name you can write like Roja. So all are these other set of the elements which are present in that particular set. Or in number, if you will see, all numbers, okay, natural numbers which are start from 1, 2, 3, 4 and so on, they are nothing but natural numbers. So natural numbers are well defined and they are the parts of the set, okay, or elements in the set. Similarly, we can say there is whole numbers which are start from 0, 1, 2, 3, 4 and so on. Similarly, integers is another set. In this there is a negative numbers will be, 0 will be, at the same time positives will be, and there is a rationals also will be. Rationals are represented with a Q. The numbers which are naturals, whole numbers, and at the same time these integers we can write in the form of p by q. Okay, so we can say that 0 by 1, 1 by 1, 2 by 1 we can write, and so on. Any number by 1 we can write it. So all these are called as rationals. So numbers which having a proper definitions, okay, and all should be distinct, then they are called as a represented in the form of sets. Okay, I hope you understood the definition. See once again, that is, set is a well defined collection of distinct objects, okay, and these objects are called as elements and represented in enclosed brackets. Okay, that is nothing but curly brackets. You can see here there is one example is given. Set of first 5 prime numbers. So prime number, if you think one particular set, in that 2, 3, 5, 7, okay, and as well as 11. So this is what the prime number is. I hope you understood. Let us go to the next one. How we can able to represent these sets. Basically, sets are represented in two ways. One is a roster form or tabular form. Second one, set builder form or ruler method. So basically, sets previously we were represented like a set of elements which are less than 5 natural numbers, like 1, 2, 3, and as well as 4. So the elements in this set are represented by keeping a commas between them. So then these kind of representation is called as the roster form. Okay, you may understood that is. Again I am saying, see that the elements of a set is represented by comma in between the curly brackets, then it is called as a roster form. And you can see one more example, the word January. So this January is a month name. If you will write the letters in this word as a set, then J is one element, A is another element, N, U is another element, A is already repeated, so we should not take, because definition of set indicating that elements should be distinct, means different. So A we will not write, R, and later it is a Y. So this is how we used to represent the roster form. So in a roster form, the elements are represented with a comma. The elements should not repeat twice or more than once. Okay, and most important thing, order of elements which are represented in the roster form is not an important. You can write any order. You can see here they were written in one order, I written in another order. Any order you write, but set elements are should be same. So this is how we used to represent the roster form. Next, another form of representation of a set is a set builder form. In this method, we describe the set by representative or the property is involved to satisfy the elements in the set. So the elements which are given, those elements of property should be satisfied in our representation. Let us say set of natural numbers less than 5. Previously we were written this is. So A is some set. So how to represent the same set in roster form? Already we know that is 1 comma 2 comma 3 comma 4. This set, if you want to represent in set builder form, then we say read like this: x is such that x is belongs to natural number because it start from 1. Next, its a property should or condition should be written here. X is up to 4 it is, so less than 5. Or another method also we can write this is, that is x is such that x is belongs to natural up to here same, but it is less than or equal to 4 also we can write. So both are correct only. Okay, next another thing I will write, like a set B is a 1 4 in curly bracket, okay, 9 16 25 is given like this. So if you see here, by seeing the number you have to understand are their property, like this is the first number 1 square, 2 square, 3 square, 4 square, 5 square. So if you understand their property, writing in set builder is becomes easy. That is in set builder form, x is such that x is in the form of 1 square, 2 square, 3 square. I will say it is nothing but n square form. So first number start with 1, then I can say it is n is belongs to natural. Okay, I hope you understand. Then up to where it is n is less than or equal to 5. So this is nothing but a set builder form. This is a roster form. Okay, this is a set builder form. Okay, this is nothing but roster form. So in this way we used to represent the given set either in the form of roster or set builder. In exam you will get in roster form 2 maximum cases in set builder form. So my dear students, you have to understand how to write from roster to set builder. It is repetitive question for 2 marks. So here roster form given that A, E, I, O, U are the vowels. So you will write as in set builder, x is such that x is vowels in English alphabet. Okay, so if you come to the question, another A is another set in this -2, -1, 0, okay, 1 and 2. So try to understand how to write the condition for this. Understanding is a different than the writing condition in a set builder form. Set builder form. So in set builder form, if you see, so you will write x is such that x, how it is there, it is greater than -2, so greater than or equal to -2, but less than or equal to, it is a 2. So 2 condition must be written in the same form in this way. So comma, this x is belongs to integer. I already told you in the previous slide regarding to this is, so numbers having positive, negative and including 0 are called as integers. Next another set, if you see, another set B is having numbers as like this: 1, 1 by 2, 1 by 3, comma 1 by 4, comma 1 by 5. Okay, so we have to represent this is, it is like a 1 by 1. So it is form is, first you have to understand it is in 1 by n form, 1 by n. So write in set builder form, set builder form. So B is set such that x is such that x is equals to, it is in the form of 1 by n, okay, comma n is start from 1 2 3 4 5. So n is belongs to, it is a natural number, and n up to less than or equal to 5. So this is what the writing of this set in a set builder form. Next roster form, you see that these kind of questions are important. Okay, in further classes I will tell you the many conversions of roster to the set builder. Okay, so if there is a set is given that 2 5 10 17, so these are nearby perfect squares, as like 1 square plus 1, 2 square plus 1, 3 square plus 1, 4 square plus 1. So 1 square plus 1 is 2, 2 square is 4, 4 plus 1 5, 3 square is 9 plus 1 10. Okay, it is nothing but 16 plus 1 17. So it is in the form of n square plus 1. So you have to understand this first before going to write the set builder form. So set builder form of C is x is such that x is equal to n square plus 1. Then where the n is started, you have to remember this is, it start from 1. So n is belongs to natural number. So n is up to where, so it is 4, less than or equal to 4. So this is how we will represent the roster form to set builder form. Try to recall in this class what we were completed. So we were defined the set. Set is nothing but a well defined collection of distinct object. Okay, all the objects in the set are called as elements. Next, sets are represented in two ways. One is a roster form. Elements are represented by means of comma or roster. Okay, another is a set builder form. In set builder form, the property we will include and we will write it. Okay, I hope you understood this is. Thank you. Have a great day. Hi students, welcome back to part 2 sets. If any student did not see in the previous part 1 video, please go through that. Is in that video I was discussed regarding to the what is mean by set. Set is a well defined collection of distinct elements is called as a set, and representation of sets also discussed. There is a two ways to represent the sets. One is a roster form, second one is a set builder form. Now today's class we will try to learn regarding to the types of sets. What are the types of sets do we have? Let us see. The first type of set is nothing but the empty set. Another name for the empty set is a void set or null set. You can understand what is mean of this. If a set does not consist of any element, then it is said to be empty set. A set has no elements is called empty set. Example for this is a set is having a natural numbers less than 1. Everybody knows that is natural number is a number which are start from 1, 2, 3 and so on. So less than 1 there is no possibility. So then that set is called as the null set. So null set is represented in curly bracket without any elements, or also it is represented with a Greek letter called a phi. Another example, a set is here you can see the second one. X is such that x minus 2 is equal, x square minus 2 is equal to 0, where x is rational. He is saying rational. Let us see whether it is rational or not. X minus 2 is equal to 0. So transfer to that side. X square is equals to 2. Then x is equals to plus or minus root 2. Means x values are plus root 2 comma minus root 2. So plus root 2 and minus root 2 are irrational numbers. But this set, if you will write in roster form, then set B is root 2 comma minus root 2. So this is irrational set, but they are asking rational numbers. So set B is no elements will be present in this. So it is irrational set, but they are asking rational. So answer is for this is B is actually a null set, or it is nothing but a 5. So another set, you see, X is such that X is a man living on the moon. So obviously everybody knows that there is no livelihood will be on the moon, so it is nothing but empty set. Very important point you have to remember, that is null set is a subset for all sets. So what is mean by subset? About it is we will discuss in types of sets. So try to recall the concept. Empty set, if a set is having no elements, then it's called as a empty set. Example, natural numbers are less than 1, not possible, 0. X square minus 2 is equal to 0. Irrationals are come, but they are asking rational, so it is also empty set. So the man living on moon also empty set. Next, if you see that one more type of set is a single turn set. Single turn set. So single turn set, the word itself is a single, means mono, one. If a set has only one element, a set has only one element, then it is called single turn set. Single turn okay. Example, A is having some 0. So previously I forgot to tell you that if there is a 0 is there, 0 is a one element, but not it is an empty set. Okay, it has only one element is there. Like a B is equals to minus 7 is there, then only one element is there, then it is called as single set, single turn set. Next, another type of set is finite and infinite set. So finite set means what? Finite set. So finite set is nothing but, if the elements in the set are possible to count. Okay, a set which is possible to count the number of elements, then it is called as a finite set. A set has countable number of elements. Countable number of elements. Okay, then it is called as a finite set. If a set is having odd integers less than 10, 1, 3, 5, 7, 9. So odd integers less than 10. Odd integer less than 10. So it is possible to count. Or I can say that B is a set of prime numbers less than 10. Primes less than 10. Then also it is 2, 3, 5, 7. Okay. So in this way there is a number of sets number of elements in the set is possible to count, then they are called as the finite set. Next one, infinite. The sets which are not finite, they are called as infinite. Okay, so example, set of even numbers is infinite set. For the set of odd numbers, natural number set, or whole number set. Okay, real numbers, rationals, irrational, these all sets are nothing but the infinite, because there is no possibility count, there is a number of elements will be infinite. Another important is equal sets. Equal sets means if there is a two sets having a equal or a equal number of element and all are same, then they are said to be the equal sets, like A, B, C, D are the elements. Another set is a B is having a B, C, D, A. So in A set there is a 4 elements are there, B also 4 element, all the elements are same, then it is said to be that is called as a equal set. Okay, you can see in example, a set A is consisting of watch, ring and as well as a flower. Set B also consisting of same element, then they are called as equal sets, because A is equals to B here. Okay, I hope you understood. Next type of set is cardinal number. Of course, next is a universal set. Anyway, before going to that is we will discuss regarding to the cardinal number. Cardinal number is nothing but the number of elements in the set is called as a cardinal number of the set. Let us say a set is having 1, 3, 5, 7. So number of elements in this set is nothing but 4. So n of A is nothing but 4. So cardinal number is represented as a n of whatever the set is there, set name it is. So if you say B is another set is having A, B, C, D, E. So then cardinal number of B is n of B is equals to, we can say as a 5. So this is how we will represent the cardinal number. Cardinal number is a very important term in bits point of view. They used to ask very easily, we can able to answer. So cardinal number means number of elements present in the set is called as a cardinal number. Okay, so coming to the next concept is a universal set. So the word universal means in which everything is present is called as a universal. So for number theory, what is a universal? So if you see in a number theory, the numbers which are start from counting 1 onwards, 1, 2, 3, 4 and so on, they are called as natural numbers. So natural number set is nothing but 1, 2, 3, 4 and so on. So this number set is called as a natural number. Next set of numbers, what we will call the natural number which are included with the 0, like a 0, 1, 2, 3 and so on. So this set can be written as 0 comma natural numbers. So all the natural numbers are present in the whole number, then we can say natural numbers are the subset of the whole number. Subset symbol, this is like a C will be, this is nothing but subset of the whole numbers. So the representation of or these sets will be in the form of diagrams. There is a Venn diagrams will be, if the set is a natural number is a set of whole number, then in whole number we have to represent this natural number. So in one circle, another circle we called as a subset it is. So whole number is 0, 1, 2, 3 and so on. So next The numbers which having 0 and positive, along with that is negative numbers will be, then it is called as integers. So in integers, if you observe properly, there is negative numbers, whole numbers are present, or it is negative numbers, 0, natural numbers are also present. Means natural numbers are the subset, means whole set is present in the integers, whole numbers are also present in the integers. So I can say that natural numbers are subset of integers and whole numbers are also subset of integers. If you combine these two, we can write natural numbers are subset of integers and natural numbers are subset of whole numbers are subset of integers. Okay, so again Venn diagram will be like this. So whole numbers are present in the integers, so z is nothing but represented as a -2, -1, 0, 1, 2 and so on. Next, another category of numbers is nothing but rational numbers. The numbers which can be written in the form of p by q, where q is not equal to 0, so they are called as rationals. So here all integers can be written as rationals, like a -2 by 1, -1 by 1, -3 by 1. Like if there is a whole numbers are there, 0 by 1 we can write, or any number. So any number can be written as p by q up to integers. Then we can say these all the numbers are the part of rationals, so which is nothing but in the form of p by q, where q should not equal to 0. So another set of numbers is nothing but irrationals. Okay, they are represented with q dash. So these all will be present in the real numbers. So real number is a universal set. So universal set is represented with a letter called mu. I hope you understand the concept of universal. So in real number, all the sets, natural numbers, whole numbers, integers and at the same rationals and irrationals are present, then it is said to be the universal set. Okay, next type of set, let me one moment please. Next type of set is nothing but subset. It is also very important. 4 marks repetitive questions has come on this is writing of subsets and what is mean by subset. Now only we have seen all natural numbers which are start from 1, 2, 3 and so on are present in the whole numbers, 0, 1, 2, 3, 4. So all these numbers are included in this whole number, like 0, n. If one set is totally present in another set, then that set is called as a subset of it. Is nothing but natural number is a subset of whole numbers. Okay, I hope you understood. You see here, set A is having a 2, 4, 6, 8 elements. Set B, 2 is there, 4 is there, 6 is there, 8 is there. So all the elements of A is there in the B. Then A is called subset of B. A is called a subset of B. So I told you this point already. Empty set is a subset of every set. Every set is a subset of itself. If A is there, A is a subset of A only. We can say it is. A set does not changes if one or more element of the set is represented. Okay. If A is subset of B, B is subset of C, then here common is B, then A is also subset of C. Okay, so these are some of the important points regarding to the subset. Next, writing of subsets is very important. If there is only one element is there, first, if there is a set is having only one element is there, so how many number of subsets are possible? So number of subset formula is 2 power n, where n is a cardinal number or number of elements. I hope this concept is very useful to you. Okay, so there is n is equals to 1, so 2 power 1 is nothing but 2. So number of subsets will be 2. So all subsets are nothing but first only one element is there. How two subsets are possible means first is empty set, another one is a set. So this is what the two sets are possible with the A. If you take that is a second, if there is a B is another set is having a 10 and a 100, two elements, then number of subsets are, so n is equals to here 2, so 2 power 2 is a 2, 2s are 4, so 4 subsets are possible. So all subsets are, first you write null set, then single element, then another single element, so double element. So in this way we used to represent 4 possible subset of 2 elements. If there is a third thing, if there is 3 elements are there, like a C is another one, A, B and C is another set. Okay, then how many number of subsets are possible? So n is equal to 3 here, number of subsets formula 2 power n, 2 power 3 is equal to 8 are possible. So here there is a trick is there, but you can write easily all subsets, so all subsets is nothing but first is null set, so next single element, okay, next A with B, next A with C, next B element, B with C. So up to here 2, 4, 6 are possible. So total 8 should be. So we can write as another is all 3 together. AC is another set is AB is possible, BC is possible. Okay, and one more is possibility A, AB, AB and AC, BC. Okay, C is another set is possible here, and one more is A comma B comma C. So in this way there is totally 4 pairs should be, yes, absolutely done. So 4 pairs, it is nothing but all together we have 8 sets are formed. If there is a 4 elements are given, separately I will make a video on that, is how to write the subsets, or during a discussion of numericals I will tell you if there is a 4 elements are there, how to say number of subsets. Okay, so this is about the today's concept up to subsets. So in this class I usually discuss what is mean by empty set. If there is no elements are there, then it is called empty set. Second, finite set. If there is a number of elements are possible to count, then it is called finite. Infinite set, there is no possibility to count, like even number set, odd number set. Okay, singleton set, it means if there is only one element is there, is called as a singleton set. And equal set, if there is a two sets having a same number of element, then it is called as equal sets. Next, subset, this is what the subsets. Okay, I hope you understood. Have a great day. Thank you. Hi students, welcome back to sets part 3 video. My name is Hatiram. Let us start today's class with the Venn diagrams. So in previous class we were discussed regarding to what is mean by sets. If you are not seen and representation of sets, please go through the video 1, part 1 video. You will understand it is. Next, there is a different types of sets are there. So types of sets already we were discussed in a part 2 video. Today we are going to discuss regarding to the sum of the operation and representation of sets with the help of diagrams. Those diagrams is called as Venn diagrams. So Venn diagrams gives a relationship between the sets. So this may be they will ask in bits. Try to remember that is. These diagrams are consisting of a rectangular and closed curves, usually circles. So if there is a set which consisting of 1 to 10 elements and a set A is a subset of it is, then it is represented as a simply it is nothing but a universal set. Set A is a subset of the universal set. It is consisting of 2, 4, 6, 8, 10. Remaining 1, 3, 5, 7, 9 are present in this universal set. So this is how there is a Venn diagrams are represented. Already I told you the diagram of a Venn in regarding to the discussion of universal set. I told you when there is a set is subset, then we will represent within the set it is. Okay, so let us go to the sum of operations which are related to these sets. So there is a two basic operations are possible with the help of sets. Okay, those are one is called as a union operation. So union of set is represented if there is a set A is there and B, then union is represented as a union B. This word generally you can understand. Outside there is some unions will be formed. So those unions work for the people together. Okay, all together they used to work for something. This is how union means. If there is a two sets are there, then we will combine them and we will write so that is what the union of sets. So symbol for the union as like a U only will be. Let us say if there is a set which is having elements 1, 2, 5, 7 and 9. Another set is B is having elements like a 2, 4, 6 and 8 as well as 9. So in this way there is a two sets are there. So I want to perform the operation called union, A union B. Then first write the set A 1, 2, 5, 7, 9. Set B is nothing but 2, 4, 6, 8 and as well as 9. So union means we have to combine the both sets. If there is any element is repeat twice, we will replace it is with once a time. So 2 is repeated here and 9 also repeated. I think so these are the terms are repeated. So now combine this 1, 2 is repeated, so 3 is not there, 4 is there, 5 is there, 6, 7, 8, 9. Okay, I hope you understand. Just we will combine them as like this. So in Venn diagram how to represent this is in Venn diagram. So these are the natural numbers. So it is nothing but a universal set of natural numbers anyway. So set A and set B having two common. So this is A set, this is a B set. Having a common is a 2 and as well as a 9. That is we will write first. Then we will make use to complete the set 1. 1 is A is having a 1, 5 and a 7. Set B is having a 4, 6, 8. Okay. So this is so while performing union operation, we have to share the sets so such a way that it could be shaded a whole shading is done during a okay. So with pencils we will make in a so it will be visible by the numbers which are written with the pen. So this is how there is a Venn diagram of A union B. Okay, so you may understood what I spoke here. Just union means combination of two sets. Okay, next operation is a intersection of two sets. Okay, so let us see intersection of two sets. So intersection means common point it is. So intersection of two sets, intersection of sets. If there is a and B are the sets, so intersection is A inverted U B. Intersection we will call intersection of two sets. So intersection, common point means if there is a common elements are there, those common elements we used to write here. So let us say A is a set, A is some set which is having elements like a 5, 6, 7, 8. Another set B is having elements like a 7, 8, 9, 10. So we have to perform an operation called intersection. So I told you clearly 5, 6, 7, 8 and intersection there is a 7, 8, 9, 10. Okay, intersection means common is what is there here, 8 is there common, 7 is there common, so 7 and 8 are common, so that is only our answer is 7 comma 8. So this is very easy, every student can able to do this kind of operations. So there is no much difficulty as like in roster form to set builder, such a difficulty also will not be. Common whatever there, that is only. So shading also do for the common here. This is nothing but universal set. In this there is a set there, at the same time set B also there. So here common is one element is, you know, that is 7 comma 8 common elements. So try to see what is the terms are left, 5 comma 6, here 9 comma 10. So common what is there, shade that part. Anyway this is 7, shade that part. So that's all. This is what the intersection. So this is A intersection B. Intersection, during that you have to share the common region between the two sets. Okay, I hope you understood this. Next, disjoint. So name itself is there, disjoint sets. So disjoint sets means whenever there is a intersection operation is performed, or if there is a two sets are there, in between the two sets there is no common element is there, then it is called as a disjoint sets. Let the set A is even numbers less than 10, like a 2, 4, 6, 8 less than 10. So B is another set, okay, odd numbers less than 10. Okay, so do I forward 2, 4, 6, 8. Okay, done. So if you perform intersection A intersection B, then 2, 4, 6, 8 intersection 1 3 5 7 9, there is no common element is there, then result is nothing but null set. So the intersection of two set is a null set, then A and B sets are disjoint. Disjoint is there is no common, joint only not there, common is not there, then we will call as a disjoint. So Venn diagram representation is A is separate, B is separate. In A 2 4 6 8, here 1 3, okay, 7 and as well as 9. Okay, so in this way we used to represent disjoint sets. This is A and this is a B. Okay, there is no common between them. Okay, I hope you understood this. Next, this is another operation you have to know, that is nothing but difference between the sets. So very simple difference. Let there is a set A is there which is having a 1 5 7 8 10 elements. Set B is having a something we can take it as a 2 5 8 9, another set is. So if you want to perform an operation A minus B, then you can understand first with Venn diagram easily, removing of a B from the A. So here there is a common is there 5 5 8 8, so 5 and 8 are common there, rest of elements 1 7 and as well as 10, here 2 as well as 9. So when you want to remove B, then let me take one more pen here. So when you want to remove B, this is A and this is nothing but B, this is universal set. B totally you have to remove up to where it is, B is up to here. So what is the rest is left, that is we have to shade here. So that is what the answer now. So B total you have to remove, this B total we have to remove from the A. So 1 5 7 8 10 minus it is 2 5 8 and 9. So what is the common is here, 5 and as well as 9 are common, sorry 5 and as well as 8 are common, 8. So rest is left 1 7 10. This is what the A minus B. Similarly I want to perform a B minus A, B minus A. So same thing, now this time we have to subtract whole B, sorry A from the B. So 5 and 8 same question I am taking. So it is a 2 9 1 7 10. So A I want to remove, A should be removed. So when I want to remove A, so A is present up to here. This whole if I will remove, then this is what the answer, that is we have to shade it. So let us say 1 5 7 8 10. Okay, next sorry minus, right, we have to go with the minus here. So minus it is simply 2 5 8 and as well as 9. Sorry, I made it reverse. B minus A I have to do it. First we have to write B, then we have to write the A. So B is 2 5 8 9 minus it is A1, 5, 7, 8, 10. So here 2 and as well as 8 are subtracted. So 5 and as well as 5 and 8 are subtracted. So answer is 2 and as well as 9. So if you observe here, A, this is A minus B, this is B minus A, both are not equal. So A minus B is not equal to B minus A in case of the difference of two sets. Okay, the last concept, very important concept in class 10th. Okay, most of the time 4 marks question is asked on this fundamental theorem of sets. Okay, so what is the fundamental theorem? Is nothing but n of A union B is equals to n of A plus n of B minus n of A intersection B. This formula also can be written as by interchanging these two. Okay, that is n of A intersection B is equal to n of A plus n of B, okay, minus n of A union B. So this is what the very important concept. Let us say there is a question will be asked. Previously we were done, and let us say one example will take it. A is having a 2, 3, okay, 4, 5. B is having a 3, 5, 8, 10, 11. Okay, so say first cardinal number of A. Cardinal number is nothing but 4. Cardinal number of B, it is nothing but over 5 is there. 1, 2, 3, 4, 5 is there. Yes, done. So n of first A union B do it, then A intersection B do it. A intersection B. So directly we can say, so union, if you see union 2, okay, then 3, next 4 over 5, next 5 after 6 not there, 7 not there, 8 is there, 10 is there, 11 is there. So from this is n of A union B, that can be written as A union B. How much more? A union B, how many elements are there? 1, 2, 3, 4, 5, 6, 7 is there. So it is 7. Similarly, intersection common is only 2 and as well as 5. That's all. So 3 and 5 are this is. So n of A intersection B is equals to 2. So now see that LHS part in equation 1. If they used to ask to prove it is from 1, LHS is nothing but n of A union B is 7. Similarly, RHS, if you see, n of A union B, n of A is 4, n of B is 5 minus 2. So it is 9 minus 2 is equal to 7. So LHS is equal to RHS. Okay, hence the fundamental theorem is get proved. That is n of A union B is equal to n of A plus n of B, okay, minus n of A intersection B. Okay, so this is what the very important question will be asked on the basis of fundamental sets. Okay, my dear students, I hope you enjoyed this class. Have a great day. Thank you. We will join again with the help of all the questions in this lesson, from the do these, try these, and along with the exercise, all questions along with examples I will discuss in the remaining classes. Have a great day. Thank you.